So let's first check out f of 2. If I evaluate that function at 2, I get 0 over 0. So this is undefined, which by our conditions up there, 1 is violated, it is discontinuous. All right, so it is discontinuous at x equals 2 for that reason. Now, if we carried on and took the limit as you approach 2 from beneath, well, this actually equals, if we factor this out, x plus 2. So the limit coming from the left is 4, which is the same as the limit as you approach 2 from the right. And so the limit exists, however, because the function does not exist, that does not work. Okay, but that's just kind of worth noting. Right. So if the function is defined, we might continue moving on. Okay, so part B, first is f of 3. Is f of 3 defined? Well, x equals 3 would appeal to this part of our piecewise function, so let's plug 3 in there because it is a quadratic. We can do that. That would be negative 9 plus 4, so that's negative 5. f of 3 is negative 5. Okay, so it's defined there. It is defined there. The question is, does the limit exist? All right, so the limit as x approaches 3 from beneath of f of x, that would appeal to that first function, so that limit is negative 5. Limit as x approaches 3 from above, that would appeal to the denominator, the second function, the second part of our piecewise function. Evaluating that at 3, because it is linear, that will be 4. All right, so the function exists. The limit as a whole does not exist because those two are different. So part 2 is violated, and this function is discontinuous. Discontinuous at x equals 3. Okay, part C, we've actually looked at this function previously, and we determined a couple of things, well, mainly the limit. So we'll get to that in a second. But if I evaluate this at 0, well, that tells me I need to use this. So f of 0 is 1. All right. Now, the limit as x approaches 0 of f of x, as we approach 0, is actually going to involve the upper function. We're not at 0. We are getting close to 0. And we looked at this quite a bit. That limit is 1. From the left and the right, it is 1. So this is actually a continuous function. It's continuous at x equals 0 because of that second definition of the piecewise function.